All right, so number 18, the last one on Unit 5D, says make up a context for the expression, and then it's 4,000 times 1.005 to the 12th, where the 12 refers to 12 months. Okay, so this is one of those exponential growth type expressions. And if you look right here, it's growth because the base is greater than 1, so it's growth. We're compounding 12 times. So we could think of it as like you invest $1,000. Oh, sorry, $4,000 because this is the initial amount at a rate of, and now it's not 100.5%. Remember, to turn that into a percentage, you would multiply by 100. So it's 100.5. But that 100 is the original percent, and the 0.5 is how much it grew by. So at a, we'll say, growth rate of 0.5% per month for 12 months. Okay. Now there's another one down here, right? Notice it's the same thing, but now it's raised. It's raised to the n. So this number right here, that second term, 4,000 times 1.005 to the 12 n. Okay, this is kind of the same deal, except now I'm raising it to the nth power. This is the same thing as saying 4,000 times 1.005. And we have a rule that says if you have something to a power to another power, then the powers multiply, b times c. So this one would be 12n. Now, if you think about it, 12 is 1 year. So if I multiply it by n, then I'm really saying how much this thing is after n years, right? Because after 2 years, it would be 12 times 2, then 12 times 3 for 3 years. So this right here is really saying you're investing $4,000 at a growth rate of 0.5% per month for n years. Right? Now, this part right here, that's a little different looking because now that 1.005 is gone. So if we look at that one, 4,000 times 1.0617 to the n. Now, what I'm going to do is I'm actually going to type in this. So one way of reading this is you're investing like $4,000. So invest $4,000 at a growth rate of 6.17% per something for n of those somethings. Like, so if it's per year for n years, right? Now this is not just some random expression here. That's actually derived from this one up here. So let me show you this. 4,000 times 1.005 to the 12. Remember, we're saying 12 is months, so this would be 1 year. So the question could be, how do I get the yearly rate? Right now I know that 0.5% is the monthly rate. Okay, well, if I could write it as 4,000 times something to the, like if I wrote it like this, 12n, n is now years, but it's still a 0.5% monthly rate there. So if I could write it like this, 1.005 to the 12th, which I can, this thing is going to be somehow related to the yearly rate now. So let me type that in over here. 1.005 to the 12th. Okay, so the number inside here now is this other one. right? This 1.005 to the 12th thing, these two expressions right here are identical because the 1.005 to the 12th is 1.0617. Okay, well, these two formulas are identical, right? This is the monthly rate because of the way that it's structured with the 12n. But this right here, I've taken that 1.005 to the 12th and turned it into its own number. And that number is now raised to the number of years. So this is kind of like I've created a new yearly formula for myself, and this is the rate that goes with that yearly formula. So the yearly rate is 6.17%.